Example 8.9, question B. Here is the free body diagram of a rigid body. Okay, so it's still the same rigid body, still the same object. It is 10 meter times 6 meter rectangular in size, but there are 4 forces that acted onto the body in this direction. Okay, so O here is a point of axis of rotation. Okay, so we want to determine resultant torque. Like I said before, torque equal F cross D. Okay, here is the formula. And after that, we want to determine individual torque of these individual forces. Okay, so torque for force 1, we denoted it by torque 1 equal F1 cross D. It's a cross product, means the force must be perpendicular to the distance from axis of rotation. Okay, force here is 30 Newton. And we want to determine distance from axis of rotation. You can extend the line of forces. Okay, here is the line of forces of 30 Newton. So this is point O as the axis of rotation. So it has been perpendicular to the axis of rotation. So no need to resolve this force. Okay, so what is the distance here? It is 3 meter. So 30 times 3. Okay, after that, we want to determine direction of torque. Okay, so imagine that you have one rectangular shape that is very rigid. It cannot be deformed. You pull that object to the right so that and hold at this point. So the object will rotate clockwise. So clockwise is a negative direction. Thus torque 1 equal negative 90 Newton meter. Okay. Next is torque 2. Torque for F2. Okay, here is the location of F2. If we extend the line of F2, it touched the point of rotation. Okay, torque 2 equal F2 cross D. So F2 is 10. And there is no distance from the axis of rotation because it touched point O. So it will be times 0. So no need to find direction because the magnitude of torque 2 is 0 Newton meter. Okay, so now is torque 3. Torque of force 3 times distance. Okay, cross the distance. Okay, this one is a little bit harder because the force has not been perpendicular to the distance yet. Okay, so what I do is a little bit different with the solution in the lecture notes. But this is the another step that you can do to solve this question. Okay, so I will make this line as D. Okay, so my D is 5 meter. D is the distance from axis of rotation. Okay, so if you look at the force F3 here, so F3 has not been perpendicular to D. So what we do is we have to resolve F3 going at this side, at the side of y-axis, so that when F3 moves in a y-axis, it has been perpendicular to the distance. Okay, so you have learned this from chapter 1 on how to resolve the vector, as well as you have learned this in chapter 4, forces. Okay, so we have to determine angle of beta. So how to determine the angle of beta? I can extend line of F3 here. Okay, extend the line. So another location of angle beta is here. You learn it in mathematics. This is called opposite angle. Okay. So this is a right angle triangle. You can see here, this one is a right angle triangle. You have this line, which is 5 meter, and the height of the triangle is 3 meter. We can choose trigonometry, which is sine beta. Okay, sine equal opposite over hypotenuse. The opposite of beta is 3 meter over hypotenuse of the right angle triangle. So hypotenuse is a theorem Pythagoras, okay, which is 5 meters square plus 3 square. Okay, press your calculator. Sine beta will be 0.515. Okay, so no need to arc sine because we can have subject sine beta. Remember, F3 must be perpendicular to the distance from axis of rotation. We will resolve this 20 Newton. So 20 to the y-axis. So it is 20 sine beta times d. D is 5. So that's why we are not making beta as a subject because this one asks for sine beta. So we can substitute 20 times 0.515 as our sine beta times 5. Okay, press your calculator. You will obtain 51.5 Newton meter as your torque of force 3. Now is torque for F4. So torque 4 equal F4 cross D. Okay, F4 is 25 Newton. And if we extend this F4, it is by the way touch the axis of rotation. It touch point 0. So there is no distance from axis of rotation. Okay, same as torque 2. 0. So torque 4 is 0 Newton meter. Okay, the last part is the resultant torque. Okay, we vector sum of all the individual torques. So it is negative 90, our torque 1, torque 2 is 0, torque 3 is 51.5, torque 4 is 0. Okay, so you will obtain resultant torques is negative 38.5 Newton meter. Okay, here is the magnitude. Remember, you have to also state the direction of torque. Okay, since you obtain the value which is negative, so negative is for clockwise direction.